This is Chapter 5 of Astronomy 100, Light, the Cosmic Messenger. Our goals for learning here is what is light, what is matter, and how do light and matter interact. Light is, at least what we see of light, actually a combination of different colors. If we shine a light into what's called a prism, a triangular piece of glass, it splits the light into its various colors. And for the most part, sunlight and lots of different forms of artificial light have all of the colors contained in it. Combined, we get what we call white light. This is a very nice diagram of the different ways that we can understand the nature of light. Along the top is probably the most basic, where we're looking at the different kinds of light, the different types of light, such as gamma rays, X-rays, ultraviolet, visible, infrared, and finally radio waves. But what's really interesting is the fact that you see what looks like a slinky along the top, and that is actually a representation of the wavelength, the length that each wave of light has. Gamma rays have the shortest wavelength, in other words, the distance from the crest of one wave to the crest or the top of another. X-rays are a little bit longer, and so on as we go down to the right, radio waves having the longest wavelength. We could actually measure the wavelength, and that's what the second bar scale is all about, but basically as you go to the left, they're shorter. As you go to the right, they're longer. The other aspect of light is the frequency, or how often a crest travels past a certain point to the next crest. That's called frequency, or hertz. So that's kind of in the middle of this diagram. Obviously, there are many, many more hertz, so the frequency is higher the shorter the wavelength is, and lower the longer the wavelength is. We're going to skip the part about electron volts and sources we might find on Earth. That's pretty self-explanatory. What's really interesting is at the bottom that shows the different ways in which we can use detectors of these forms of light to look at different objects in the universe, such as gamma ray burst objects, black holes, the sun's chromosphere, the sun itself, planets, something called microwave background radiation, and finally, and very recently, radio galaxies. We can use different types of instruments to look at these different wavelengths and detect things that we might otherwise not see or detect. Up until now, optical telescopes were the only way to find these objects, or find some of the objects. So, light is an electromagnetic wave. It travels in a wave form, and so that wave has wavelength. It also has frequency, which I already talked about. That's the number of times a crest would pass a certain point. But wavelength times frequency equals the speed of light, and that speed of light is constant, 180,000 miles per second, or 300,000 kilometers per second. Light can also be classified as something that has particles, or photons. Each photon has a certain amount of energy. It has a wavelength. It has a frequency. So light has kind of this dual property where it can be considered a wave. It can also be considered a particle. Matter, which we all consist of, as you probably know from a general science class, is a combination of protons, neutrons, and electrons. In the nucleus, in the middle, you're likely to find a combination of protons and neutrons. Around the nucleus, there is usually a cloud of electrons. Protons are positively charged, electrons are negatively charged, and they usually balance out. Neutrons are neutrally charged. So a typical atom would have no electrical charge because the positives and the negative balance out. The number of protons gives the atom its atomic number. So the higher the number of protons in the nucleus, the higher the atomic number. The number of protons and neutrons make up the mass of the nucleus, and so that being unique, it's called the atomic mass number. Electrons have virtually no mass, so they don't go into this calculation at all. So just remember the difference between atomic number and atomic mass. Atomic number is the number of protons. The atomic mass number is the number of protons and the number of neutrons. An isotope is something different from the regular atom. It has the same number of protons, but the number of neutrons is different. Remember, neutrons don't have any electrical charge, so they could somehow be combined with the nucleus into a different form, and that form is called an isotope. And then there's another variation on atoms, where two or more atoms of different types can combine, or two or more atoms of any type can combine to form what's called a molecule. The best example of that is water. Water is H2O, two hydrogen atoms and one oxygen atom. They form a special bond that tends to stay together pretty well, and unless you apply a lot of electricity to a water molecule, it will stay water. So how do light and matter interact? Well, there are four ways that the book describes. By emission, light can emit and matter can give it off. Light can be absorbed, light can be transmitted, and light can be reflected or scattered by matter. So here's an example of reflection and scattering. On the left is a mirror, and that mirror is obviously reflecting light. As it hits the mirror, it bounces off at the same angle. And there's also scattering, such as you might see in a movie theater, where light is projected onto a screen, and that screen scatters the light, obviously with different colors, shades, whatever, and we get to see the image being scattered. These are some other examples of how light can interact with matter. The sun and, of course, the light bulb emit light. The mirror reflects light. The chair is red because it scatters red light, but it absorbs all the others. And our eyes can absorb that light so we can see it. The snow absorbs some light, which helps it melt, but it scatters the light so it looks bright. And of course, glass transmits all the colors of visible light. So that diagram at the bottom of page 111 shows all the different ways that light and matter interact. So what is light? Well, it's a form of energy. It comes in many colors that can combine to form white light. It is also a wave or a photon. Each photon has a precise wavelength, frequency, and energy. And there are different forms of light: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Matter is something that's made of atoms, which are made of protons, neutrons, and electrons. How do they interact? Well, matter can emit light, absorb light, transmit light, and reflect or scatter light. And the interactions between light and matter determine the appearance of everything we see. Remember, we can't see something unless that particular wavelength of light hits our eyes. If it's absorbed, we don't see it. If it's reflected, we see it. So any color that we might see in clothing or out in nature somewhere is a direct relationship to what that material has been able to reflect and what it absorbs.